is your topmost interface. Collection is the topmost interface. Okay. Now below that, what are things we are having? Set, list, queue. Okay. So we'll go here. The first one is your set, then list, then queue is the one. So what is the special thing about queue? It will work with first in, first out. List, it will allow duplicate data. Okay. Set means it does not allow duplicate data. Okay, it will remove all the duplication if you are having. Then below that set, what will be there? Has set. Okay, H should be capital. Why? Because all the class and interface first letter capital. Then tree set. What is the third one? Linked hash set. What is the special feature about tree set? The data will be sorted. So sorted means tree by default only. Okay, and automatically tree set will implement on the method called interface called sorted set. Okay, and what is the special feature about linked hash set? It will maintain the insertion order. That's what we have seen. Okay, so if somebody had come first, then while retrieving also it will come first. Okay. Yeah, so this is the one. Then we have studied list. So what all lists are there? Tell me. Array list, then linked list, and vector. So what is the feature about what is linked list? Linked list, again, it will maintain the order of your insertion. Okay, and linked list will implement list also. It will implement queue also. So this is the special thing. No other data structure which implement to interface. So this is the one which is implementing to queue also and list also. Okay, and in queue what is there? We are having priority queue. Okay, then what is below? We are having one of the interface called map. What else things are there? Hash map, then tree map. Okay, then hash table, then concurrent hash map. Okay, so now tell me, map we have done, right? So now map will have two methods. What are the put and get? Put to put the data, get to get the data. Okay, now there are three ways to iterate through the map. What are those? Entry set, key set, and what is the third one? Values. Okay, so there are three ways by which you can iterate through the map. Okay, yeah, now let's start Eclipse. Okay, apart from that we are having, there are two utility class. Okay, so what are those? Object will be the super class of it. So what are those? Arrays, and what is the one? Collections. So arrays is used to do the operation, array operation, and collections is used to do the some sort of operation in collection. So suppose, tell me, if I want to sort a list, how I'll do? Collections dot sort. If you want to search some data in list, what to do? Collections dot search. Okay, so automatically collections will have one of the method called sorting, searching. All those methods will be there. Okay, now similar to this, if I want to do the sorting of set, how will do? How will do? Tree set you can use. Okay, or else what is the other way? You can do collections dot sort and pass the set. Automatically it will become sorted basically. Okay, sorted means increasing order, ascending order, and by default it will be ascending order. You can make it descending also by applying some rules. Yeah, now tell me, which all data structures or collection are some sound is coming. Okay, so which all data structure or collection are synchronized by nature? First one is your hash table. What is another one? Vector. Concurrent hash map also is synchronized. Okay, hash table. So hash table, then concurrent hash map, then what is the one? Vector. So these three are synchronized. Okay, Yeah, so now tell me, if I want to make my set synchronize, how I'll do? Got it, right? Because you don't have any call, I mean any interface or class which is synchronized here in set. Then what to do? Hey Tarun, so Tarun, close. Okay, so what will happen? What we want to do is very simple thing. The set which you are having, all these classes are not synchronized. You want to make it synchronized. So synchronization is also one of the utility class, right? Utility function or method which you want to do. Then whenever you want to do some utility things, whose help you take? You usually use collections. Okay, so very simple. If you want to take, if you want to do those things, what to do? What to do? You go over there and write one of those collections dot, as soon as you will do dot, automatically some method will come up. Synchronized set. Okay, and you just pass this set the object you pass, automatically it will become synchronized. Similar to this, if you want to synchronize list, you can use vector, or else you are having one more option called collections. Okay, dot synchronized list, and you pass the object the list, automatically it will become synchronized. So whenever you are stuck, you don't have any sort of collection framework or the class, what you do, you simply use the collections. You do the collections dot, all these methods are static method. Okay, you can directly use it. Okay, okay, now let's try to discuss this null key and null value combination for now. Okay, so the one which I was talking about is, see here, collections dot synchronize list. If you want to make it here, I want to make my map as synchronized, then what will do, just pass map, and this is a map, right? So student record, that's all. Then what will happen, this student record is not a normal map, it is synchronized map. So whenever you want to make it synchronized, you use collections dot synchronize map, that's all. Okay, what is the other one? Sort, collections dot sort, you just pass it, automatically it will become. Okay, yeah, now let's try to discuss about null key and null value combination. Okay, so first we'll start with the hash map. Okay, let's try to put some null key for hash map. Okay, so what is the map? This is hash map, and we are iterating through it, so we'll just put it on the front. Okay, there are other ways to iterate, so let's try to, I'll comment it when you do the other way to iterate. So maybe we will use this. We can use any way to iterate. This is the first way by which you can iterate. Okay, this we have already done in the previous tutorial. Okay, so now what is the first thing we want to see? Whether hash map supports null key or not. This is very typical question, huh? Be very careful over here. So I want to make my key as null, so suppose I'll make my key as null. Okay, so if I run this code, if it will give me the data, then it is correct. If it is not giving me the data, it is wrong. Okay, let's run this code. what we are getting, null j. So what is the key? Null key. So does HashMap supports null key? Yes, it supports. Okay. So instead of this, what we can do, we can, instead of iterating, you can use some sort of method also to work with it. Something like how to get a data, get. So student record dot get. Okay, I want to pass null. What is the data I will get? Zen. Okay. So let's try to run this code. We are getting the Zen. Why? Because I am passing null. So now try to understand. If I'll make two value as null. Now tell me what should be the data, Suman or Jen? Suman or Jen? Because the compilation is fine, right? No problem at all. Only one null key, right? So what should be the data? Tell me, Suman or Jen? Suman? Suman is not your name, so that so yeah, so data will be Zen. Okay, so now let's try to see this. What is the output we are getting? Zen is the output. Okay, so try to understand how it works basically. Okay, so typically what happens, I mean in C++, this particular problem is called I forgot, key I forgot the particular word, very important. I mean in your college you will get this question. Okay, so okay, let it be, whatever things are there. Okay, so in C++, okay, so if you are having two key and two value, then it will have some sort of different structure. But in Java, how it works is, try to understand. You are having one is mapped with Tarun. Okay, 2 is mapped with Bikash. Null will be whenever you are adding. Okay, so first one, this code executed, this is the one. Second code executed, this is the one. Third code, name will be mapped with whom? Suman. Okay, as soon as your line number 18 will execute, what will happen? It will override this Suman to Zen. Okay, so now the same place, because you cannot have duplicate keys, you can have only one key in HashMap. Then what will happen? It will override this data and it will become Zen. So what is the latest value of null? Zen. So that's why we are getting the value called Zen over there. Got it, right? So what we understood over here is HashMap supports null key, but only how many null key? It will support only one null key. It will support only one null key. It does not support multiple null keys. Okay, let's try to look into this null values. So just note it down that HashMap supports null key, but how many? Only one. So HashMap supports only one null key, because as soon as we are trying to put the other one, what is happening? It is overwriting the previous data. So I cannot have multiple null key. Okay, so only one null key. It's not about only null, any data. I mean, okay, so suppose, tell me, I will have over there, I will write here, okay, test, and I will do with 2. Now what should be the data? Tell me, Vikas or test? Test, because the latest one will overwrite your previous data. Okay, so let's see. So test is coming. So test is always the latest one will overwrite your previous whatever data you have got. Okay, so this is the one which let's try to have null value. Okay, for time being we will make it 5. Okay, and we will make it 9. Okay, yeah. So if I'll make, so any problem compilation, no problem. So what happened, null value is supported during compile time also, there is no issue. Okay, now let's run this code. What is happening, 3, how many null is coming? So it supports null value also. So hashmap supports null value also. Okay, yeah. Now let's try to have whether it supports multiple null values or not. Okay, so now if I'll have multiple keys here, if I'll do 3 then 4, then how many times null should come? 2 times. Okay, this is different null, this is different null. So typically what is happening, try to understand. So key 3 with some name will be there, any name which you have added. Then what is the one, sorry, 3 with null, right? So it will have null. Okay, with 4 also what is coming here is null, and with 5 we are having, we already have it. Okay, so and with 5 what is map, Zen is map. So now if I am doing 3 null, 4 null. So what we understood here is, as I am getting 2 null means what happens, hash map support multiple null values. Okay, so that's what we have to write over. Okay, so it supports multiple null values. Okay, yeah. Now if we'll go over there, hash map we understood. Okay, now let's try to go and see this tree map. Okay, so whether tree map supports null key or not. So we'll go here and we'll do this null key. We'll check whether tree map supports null key. So how will we do? Very simple here only. Instead of hash map, I want to check tree map. We'll make it to tree map. Okay, for timing initialization we will give actual value, whatever those value will have. Okay, so I want to see whether tree map will support null key or not. So how I can check? I just have to pass some key over there. So suppose I will make here as null. Okay, and I will try to retrieve the data from null. If it will work, then I will come to know that it supports null key. If it does not work, it will not work. As simple as that. Okay, so let's run this code. So what we are getting, see, what is the exception we are getting? Null pointer exception. So what does that mean? Tree map does not support null key. Okay, now let's try to understand why it does not support. Okay, so what is tree map? Tree map is sorted map. Tree means sorted, as I told. Now tree map sorts its data based on keys. Okay, now if I'll tell you, so tree map, what we understood, tree map sorts its data based on keys. Okay, now let's try to understand. If I whatever key we are having, 1, 2, 3, 4, 5, then null. Okay, if I tell you please sort these data, can you sort? Can you sort? We can't sort. Why? The problem here is null. Got it, right? You cannot compare anything with null. That's what we have seen, right? Got the point, right? So if null is not there, then very simple. My sorting is 1, 2, 3, 4, 5. But as soon as you are having some other data called null, now you will not be able to sort it, because you can never compare any data with null, which you have already seen earlier also. As soon as you will do null dot anything, I mean it will give a null pointer exception. So similarly here also, internally, as soon as you are making in map, what is happening? It is sorting all these keys. Now while sorting, what is happening? It is trying to compare the data with null. Now as soon as you will compare the data with null, automatically it will fail, right? So that's the problem here. Okay, so that's why we can never have null keys in tree map. Okay, so that's what. So null key, no, not supported. So null key is not supported in tree map. And if somebody will ask why it is not supported, because tree map sorts its data based on keys, and if we have the key as null, we cannot sort it, we cannot compare. So if we have the key as null, we can't compare null with other keys. Okay, so that's why tree map does not support null key. Let's see null values, it will support or not. Okay, we'll go here. So it is null, it is not supporting. I will make it to 5. Here also I will make it to 5. Okay, now let's try to make it null here. Okay, here also I will make it null. If it supports, I should get the data called null both the places. If it does not support, then some problem. Okay, so let's try to run this code. What is the any problem? No problem. I am getting both the nulls. Okay, so what we understood here is supports multiple null values. Why it supports multiple null values? Because the comparison is not getting done based on the value. Okay, comparison is based on the keys. Okay, and the last one is hash table or concurrent hash map. Both are same. Okay, because both are synchronized, right? So both will behave in that way only. So null key, whether it supports or not, we'll check it, whether it supports or not. So how to make it? Here just remove it and we will make it hash table, because we want to work with hash table. Okay, we will start with key, then we will go for values. Okay, yeah, so let's try to have one key called null here. Null, I will make it null. If it supports, then it's fine. It doesn't support, then not support. Okay, so then we will see the explanation why it does not support. So let's try to see this, what is happening. Again, null pointer exception. So what we understood here is hash table and concurrent hash map does not support. Okay, so it is not supported. It does not support null key. Okay, it does not support null key. Now why it does not support? Okay, so because try to understand what is hash table. It is synchronized hash map. What is concurrent hash map? It is also synchronized. Okay, so now during synchronization what happens, whenever you want to put the lock, okay, so you have to take care of the data which is there in your hash table. It you have to take care of your key also, you have to take care of value also while synchronization, I mean. Okay, so when we study multi-threading, that time you will come to know basically. Okay, so now whenever you are taking care of, you have to do some operation on that data, whether it can be key, it can be value also, right? So now whenever you do the operation on null, it will give you null pointer exception. That's why it is not getting supported. Got it, right? So why it doesn't support? To make the class synchronized, we have to do the operation on key and value both. What sort of operation we will do? We'll check it in multi-threading. So now as soon as you will do the operation on null, it will give you not supported. Okay, now let's try to look into the value, null value. Will it support? Again it will not support. Why? Because as I told, we have to do operation on both key also and value also. Okay, so let's try to check over here. I will make it 5. Okay, and what I'll do, I'll make it null. I'll try to get the data. It is restriction not supported. Okay, so this hash table and concurrent hash map does not support null key also, it does not support null value also. Okay, so this is very typical interview question, written test also sometimes. Okay, so yeah, this is one other thing. Now what is the other assignment which I have given? A difference, right? What? Compare to you can do. So that's what यहाँ पे what happened? Okay, so tree map, what it does is internally it will sort based on the keys. Okay, value will be considered when you want to compare internally. I mean, you want to write your own logic. Okay, so that time you can write something like, if the value is null, then don't compare, some sort of logic you can write. Okay, but now what is happening, this is already internally implemented, right? So internally it will check your keys, that's why it is not getting supported. Okay, so there are other ways, I mean, to compare. Okay, so if you want to sort, compare to, okay, compare to, or else compare. Okay, these are the two ways. So this one will come from comparator, okay, and this one, other one is your comparable. We'll see while going through. Okay, so what are those methods? Okay, yeah, now now where are we? What is the one more question which I told. What is the last one? Array list, linked list, and vector. Okay. So let's compare array list, linked list, and vector. People will ask who is fast, who is slow. Okay. Suppose if somebody asks array also, so there are 4 things: array, array list, linked list, and vector. Okay. So the order is very simple. Why? Because array list is developed on top of array only, right? So who is the fastest? Array will be the fastest. Okay. And who is the slowest? Vector is the slowest. Why? Because as we have discussed, whenever we are having synchronize, it will add some sort of extra complexity. So because of extra complexity added on synchronized collection, vector will be slowest one. So this one should be here on this side. So array is the fastest, vector is the slowest. That is very simple. Okay. Now the problem is in array list and linked list. So to compare array list and linked list, you have to understand the internal structure of array list and linked list. Okay. So let me open something. Okay. So try to understand how array list is structured, how linked list is structured. So array list structure will be how it would be. Array list structure will be something like this. Okay, and you will have some sort of like this. Okay, and here one line will be there. Okay, here you will have index. So array list take care of index. Okay, so here we will have 0 index, here we will have 1 index, here we will have 2 index, okay, 3, like this. Okay, if I may, you are having any data, 1 data, 2 data, 3 data, 4 data, I mean all those are 5 data will be there. So this is the internal implementation of array list. So array list take care of index. So index will be here, this index will be there. Okay. Now what is linked list? In Java by default it is doubly linked list. What is that? Doubly linked list. So doubly linked list, how it would be? First data, then there will be one link from here to second data, here will be your second data. Doubly means you will have reverse also. You will have one more data here, here, here. Okay, so all will be doubly linked list. So like this, back also like this. Here also forward, here also backward, here also forward, here also backward. So like this. So this is the structure of your doubly linked list. This is the structure of your array list. Okay. Now if somebody will ask who is fast, this and this, then what should be your answer? What should be your answer? Array list is also fast, he is also fast. Okay, so something like try to understand, this is based on the operation what you are performing. Okay, so suppose let's try to go back to our school days. Okay, so in school days our parents will be very much curious about our marks, right? How much marks you are getting. Okay, so what you told, I mean suppose my name is Tapas. Okay, so I am having some of my friend. Okay, any name. Okay, so suppose Samar is the friend. Okay, so my parents, he called me. Okay, so hey, how much marks you got? So I told, yeah, I got 5 marks more than Samar. Okay, so my parents is very happy. Yeah, my kid is doing good. Okay, so he is getting good more marks than Samar. Okay, so what I told my dad. Okay, so I got 5 more marks than Samar. Okay, then he is very happy. Okay, but he does not know that Samar has got 0 marks. Then how much marks I got? 5 marks. I am not even passed. Are you able to understand what I am talking about? Okay, so it is based on the comparison whom with you are doing. If I'll compare with maybe some people, they are getting maybe 95, 98 marks. Out of 98, 5 is, I mean, you cannot compare only. Are you able to understand? So it is based on the comparison, how to, with whom are you doing. Okay, so similarly here also try to understand whenever we are doing this comparison. Okay, so there are different criteria based on that. Okay, similarly here also, as I told. Okay, so suppose I told, yeah, I got 5 more marks than Samar. Then I told here star in maths. Maybe in other subject he got more marks than me. I don't know. We don't know, right? So similarly here also what we can say is array list is also fast, linked list is also fast based on the operation which you are doing. Okay, similarly as I told here math or chemistry, what subject you are talking about. Okay, so similarly here also based on the operation. So what is the operation we can perform in your data structure? Okay, so what are the operation we can perform? Insert. Okay, then update we can do. Insert, update will be almost similar. Then delete. What is the last one? Search. This is the operation which you can perform. Okay, and what is SEARCH, and what is the last one? Last one is something called who will consume more memory. Okay, so memory utilization. Sometimes people will ask this also, memory utilization. So based on those 4 criteria, we can compare both of those, array list and linked list. Okay. So now let's talk about insertion. So I want to insert some data in array list. How I'll insert? Tell me. How I'll insert? So let's go and check it. This is your array list. I want to insert one data here at maybe here somewhere. First data. Okay. So how I have to do? Try to understand. I'll insert one new data here. I'll insert one new data. Okay, and this data I have to move it to here. Got it, right? So now this data will be moved to down. This data will be moved to down, and this data will be moved to down. Okay. So what happened? And we have to put one new one where your 5th index will be there. Got it, right? So because of one small insertion, this one we have inserted. What happened? All the other data are getting affected. So you are doing operation with all the other index also, right? Next. You are changing the index over here. Got it, right? So this is your array list insertion. Now if I want to insert something in linked list, how I'll insert? Observe very closely. I'll just cut this link, put over here. I'll make one data here, and this one what I'll do? I'll make it to this one. Got it, right? I'll cut this. What I'll do? I'll make it to here, and from here to here. That's all. So when I am inserting one data in linked list, how many nodes are getting affected? 2 nodes. This one and this one. Others I am not touching only. I am not touching at all the other things. Are you able to understand what I am talking about? But in case of array list, what is happening? As I am inserting here, all the other nodes are getting affected. Means you are doing some sort of rearrangement, right? So who will be fast? Linked list will be fast. Why? Because only 2. Other things are as it is. I am not touching only. Okay. So insertion will be fast. Linked list will be fast. Linked list will be fast. Okay. Why? Because array list takes care of index. So whenever we insert all the other data will be impacted. Not only that data, all the other data impacted because of rearrangement. Right? Due to rearrangement. Okay? So due to rearrangement. Okay, so that's why your array list is slower, linked list is fast. Okay, update we will discuss after some time. Let's go to delete. Okay, okay, so now I want to delete. Same case, I want to delete this node. So what will happen? You have to delete it. Then what you have to do? You have to just make one here, this one here, this one here. Why? All the index will become one up. Why? Because you are deleting one data, right? So all will up. Okay, but in case of here, if I want to delete it, what I'll do? I'll delete it. I'll just make this here, here. That's all. So only two nodes are getting affected. Are you able to understand? So in case of deletion also will be fast, linked list will be fast. Same reason. So why? Because if we delete it, only two nodes are getting affected. Okay, previous node and next node. Same reason, because of rearrangement. Okay, now let's try to do the search. Okay, so suppose I want to search some data. So who will be fast? Tell me. Array list will be fast. Why? Because it is taking care of index. So I need 5th index. You directly go. You get it. No problem. You got this data. I need 3rd data. Go to 3. Got the data. You just have to come here and directly jump over there, because you will have some plus operation. You can directly go to that particular place. Okay. But in case of linked list, try to understand what you have to do. You cannot directly jump over there. You have to traverse through. Okay, so if you want to go to the 4th data, first traverse, second traverse, third traverse, fourth traverse, then only you will get the data. Okay, but array list is not like that. You can directly jump into that from your beginning. Why? Because it is taking care of index. Index is there. Here we don't have some sort of thing. Okay, so what happened for searching who is the fast? Array list is faster. Because it takes care of index. So now I'll give you one work, okay, a small work, and I in that work you are doing more deletion. Less searching. Then which is the data structure you should go? Linked list. Okay, if you are doing more insertion, less searching, then which one you should do? Linked list. If you are implementing some task where you are doing more searching, less insertion, deletion, which one you should go? Array list. So depending upon the operation which you are doing, you should choose the data structure. Okay, both will work in the similar way only, but based on the performance and performance impacted, it will be impacted. Okay, yeah. Now tell me memory utilization. So memory utilization, who will consume more memory? Tell me. Who will consume more memory? Linked list will consume more memory. Why? Because it is taking care of two things. It is taking care of forward node also, it is taking care of backward node also. So internally two nodes are there to go to the next one. Okay, so who will consume more memory? Linked list consumes more memory because it will have both forward and backward nodes. Forward and backward nodes. Okay, so these nodes will consume more memory. Okay, so now tell me, if you want to take care of space, then which one you should go? Array list. Suppose if you are having less space in your environment, I mean wherever you are working on, in Java you are having less space, then which one you should go? Array list. You should not go for linked list, otherwise it will consume more memory, as we have already seen, right? It will take care of two nodes basically. Okay, so again, based on the requirement, you should go for any one of those. Okay, okay, so yeah, we will conclude here. Tomorrow we will look into those interview questions and we will start some other chapter. Okay, so which is the one left? Difference between concurrent hash map and hash table. So tomorrow we will discuss that and we will look into those interview questions and we will conclude this particular topic. Okay, we will start some other chapter. Okay, we will finish.